Hello, everyone. Good evening. To authors and invited guests, welcome to Technical Session 7A. Myself, Ishita Sauran, and this session will be moderated by me. On behalf of Global Knowledge Resource Foundation, it is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event is being held through Zoom today and was held yesterday, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we'll have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us Dr. Kirit Modi. Professor Kirit J. Modi is currently working as professor and head at CE and IT department, IQAC coordinator at Sankalchand Patel College of Engineering, and dean at Faculty of Computer Science, Sankalchand Patel University. He has more than 20 years of teaching experience. He has also published more than 25 research papers in repeated international conferences, referred journals. We welcome you, sir.
So thank you very much for introducing me, and so now I welcome to all the authors who join and who are presenting their work in this session. And with these words, now I'm waiting to listen all the authors who are interested to present their novel work. Yeah, thank you.
Thank you, sir. We also have with us our next session chair, Dr. M.F. Mridha, senior member IEEE, who is currently working as an associate professor in the Department of Computer Science at American International University, Bangladesh. He has also worked as a CSE department faculty member at the University of Asia Pacific and as a graduate head from 2012 to 2019. His research experience within both academia and industry results in over 120 journal and conference publications. We welcome you, sir.
Thank you. I am joining 10 minutes later because I am now traveling.
Sure, sir. No issues. No issues, sir. We'll be proceeding with the paper presentations. I'd like to invite a first presenter for the day, Edwin, with the paper titled Design and Construction of an Animatronic Head Capable of Expressing Emotions and Facilitating Therapy for Children with Autism. You may start with the presentation, sir.
Good evening. Yes, please. One moment, please.
Sure.
Could you see my screen?
Yes, sir, it is visible. Please go ahead.
Thank you. Okay. One moment, please. Thank you. Good evening, everyone. It's my pleasure to present this paper entitled Design and Construction of an Animatronic Cat, capable of expressing emotions and facilitating therapy for children with autism. This work was done at the University of the Armed Forces in Latacunga in Ecuador. This paper details the design and construction of an animatronic head capable of performing facial expressions representing the 6 basic emotions, happiness, anger, sadness, disgust, surprise, and fear, to facilitate the therapy of teaching facial expression to children with autism. First, I want to explain the definition of the problem. We focus it in three terms. The first term is autism. What about the autism? Autism is a neurobiological developmental disorder that begins in childhood and lasts a lifetime, affecting how a person behaves, how a person interacts with, communicates, and learns. It's important to mention that according to World Health Organization, 1 of every 100 children in the world suffers from autism spectrum disorder, ASD, best now autism. The second aspect is the therapy. What about the therapy? In the last times, social robots are providing effective in supporting the development of social and communication skills in children with ASD. Experts suggest that the best therapeutic results are obtained when the therapist is assisted by robots, as they can walk, talk, interact, show expression without tiring. With this knowledge, our general aim of the research is design and build an animatronic head with sensory perception capable of performing gestures and expressions to facilitate the communication for children with autism spectrum disorder, ASD. You can see in the picture the facial expressions. What about the facial expressions? There are universal facial expressions for anger, disgust, joy, sadness, or discomfort, fear, and surprise. These expressions are implicit in the humans and crucial for the formation in interpersonal relationships. And by having complex muscular structure, it's possible to differentiate these emotions from each others. The action units, what about this term? The action units are associated with the movements of eyebrows, eyelids, lips, and mouth, which are directly involved with the formation of 6 universal facial expressions. You can see in the picture these action units. We have 14 action units. 14 action units. The action units essentially is the movement of the brows, eyelids, lips, depending for the motion. You can see the mechanical and aesthetic module. We have a process. The first step is a 3D CAD. The model is a design of the shell, the construction and the assembly of the mechanism, and the final product. It's important to mention that the children with autism do not show any preference of face type. To decrease the anxiety and clearly show facial expression, an animatronic head was designed with a monkey-like appearance and cartoonish features as it can further exaggerate social cues. It is fabricated in 3D print using PLA filaments. The heads and torso structure are divided in sectors. We have three models. The first model is eye mechanism, mouth mechanism, and neck. And the final head frame, painted silver, has spaces covered with Velcro, which are used to attach the fur to the base of the head. The skin or the face and hair are modeled in silicone. You can see the eye mechanism. It consists in eyeballs, eyelids, and eyebrows, which are supported by a structure of a couple with actuators. I tell about the actuators in the next slides. The eyeball has a diameter of 32 millimeters and an eye distance of 17 millimeters. They can rotate plus minus 35 degrees on the vertical axis and 45 degrees on the horizontal axis, taking the pupil as the reference of the point. The eyebrows are 30 millimeters long and 70 millimeters apart and can rotate plus minus 35 degrees. The horizontal and vertical movements is duplicated from the one eye to other, being able to open and close the eyelids, which eyebrow moves independently. You can see the mouth mechanism. You can see in the left the model, and in the right the final assembly. In the mouth, we have the teeth, lips, upper and lower commissures, and chain. The upper part is fixed, and the lower part is movable. In these slides, you can see the neck mechanism. It's important mention in this part. We reproduce two of the three natural movements of performance by the neck human. These are the movements of rotation from left and right, and extension and flexion, excluding the lateral tilt. The extension and flexion movements are performed by the actuators placed in the movable base. The neck mechanism has a rotation of 180 degrees. For the electrical and electronic model, we have these actuators. These actuators, we use 11 actuators, micro servo actuators. The series MG19S. Yes, the distance between the load of the rotation points is 2.45 centimeters, assuming a safety factor of 1.8, an efficiency of 18%, and a loss of 50%. The kits on the torque is 8.82 kilogram force. Therefore, the MG995 servo motors with a nominal torque of 9.4 kilogram force centimeters C are selected. And the printed circuit board was manufacturing in a CNC router. What about the interaction module? Artificial vision. We use artificial vision for two tasks. The artificial vision system performs two basic operations: face tracking and face recognition. The face tracking function searches for the face at the image captured by the camera, and it found sending the coordinates by serial communication to the controller. Okay, and the face recognition distinguishes the user. It's important to mention that for the face tracking, we use a library of OpenCV based in hard cascade algorithm proposed by Bill and Jones. And for the recognition, we use deep learning. This library of deep learning is available in OpenCV. We have a graphical user interface. For the graphical user interface, we have 4 therapy activities, where designed to familiarize the user with basic emotions. The first screen is an introductory. In this screen, we have greeting welcome, and we can see the parts of the robot: the lips, the eyes, and the mouth. In the second activity, we have the basic emotions layer. In this part, we have the 6 emotions and a definition of these expression and emotions. Happiness, what is happiness, anger, sadness, disgust, surprise. For familiarize the user with the emotions and the expression of the emotions. The next activity, named recognizing expressions, is this. In this part, you can see in the pictures. It's the same that the last task. However, we have emojis for this task. In the last task, we have the definition. In this task, we have emojis. We have an illustration of a child, and in the second part of the activity, we have an illustration of a grimace. And in the last activity, we have the emotions presented in our robot. You can see in this part the emojis and our robot for practice the recognition of emotions. We develop a functional test. You can see this is the 6 expressions in our robot: the expression joy, sadness, anger, surprise, disgust, and fear. And in the second picture, you can see the mechanical capabilities. I mean, the maximum and minimum movements of each part of the robot. For example, the eyebrows, the max and min of the movement of eyebrows. The results and the discussions, we developed a test. The users were 4 children without autism, and the 3 sessions were carried out 2 days apart. We have for childs the 3 tests you can see in the table. We have in these 3 activities, we have 6 expressions, total case 72, and when the test is applied for the children, we have 67 success tests of 72 expressions. That represents 93.06%. You can see the results. Also, we have the time for each test. The mean time per test is 43.25 seconds. Also, we have to ascertain the option in especially the user friendliness of the robot is ability
Excuse
to
me,
show
sir.
a more.
I'm really sorry
Sorry?
to disturb, but I'd like to remind you of the time limit.
Okay.
Yeah.
Okay. This express is a survey consisting of close and quality part. More conclusions. We can use this project According to 5 specialist consultants, all agree that the animatronic head has a possible influence of children's learning and he is accepted. Regarding robots' ability to express the 6 basic emotions, they say that the 6 expressions are very well represented. However, the expression of disgust is highly difficult to recognize. And it's important to mention that although the project was focused in helping children with autism, these first model-based tests were carried out with normally developing children because at the development stage, the specialist did not recommend subjecting patients to possible confusion. That's all. Thank you for your time, and I will grateful for your questions and your suggestions of this project. This is this project. If you see the movement. Thank you.
Would the session chairs like to ask any question? It could be a potential technical issue. Thank you, sir. We'll be proceeding ahead with our next presenter. I'd like to invite paper presenter we have with us next. Abdel Krim with the paper titled Enhanced Hybrid Skin Detection Method Using Multiple 3D Volumes and Threshold Optimization. So if you're here, then you can start your presentation.
Can you hear me?
Yeah, sir, you're audible.
Good afternoon, everyone. I am Abdel Karim Hanoun, and I am very delighted to be with you to present our work on skin detection. To ensure its clarity, our presentation will be organized as follows. I will start with introducing the most important topics related to the topic, points related to the topics. After that, I will present our method. Then I will present and discuss the result we obtained. And finally, we will have a conclusion and some perspectives. Let's start by defining skin detection. This task can be defined as the identification of skin regions within an input.
Will you be presenting your presentation? Like, will you be screen sharing your presentation?
I didn't share it. Sorry.
No.
Yeah. Sorry. Yeah.
It's okay. You can share it now.
Should I restart or resume?
No, you can resume. You can resume. You can share the slide.
I don't have to restart. I'm sorry. Yeah. So let's start with defining skin detection. Skin detection can be considered as the identification of skin regions within the input.
Really sorry to disturb you again, but you haven't shared your slide once again.
Oh.
It's not here. Maybe you can start sharing it again.
I didn't click on the button. Yeah, share. I'm sorry. I just selected the screen. Yeah, I'm sorry. And now?
Yeah, it is
How
visible.
about now?
Please go ahead.
Okay. So skin detection can be considered as the identification of skin regions within the input, as we can see here, which makes it a very important pre-processing step in computer vision applications, especially the human-related ones, such as hand gesture recognition and human-machine interaction, and so on. So skin detection methods are generally classified into two main principal categories, which are rule-based methods that mainly relied on thresholds, and machine learning-based methods, in which the different machine learning techniques are used, and several visual features are employed in these methods, and you can guess that color and texture are the most popular ones. And between these two features, color is the most used one, mainly due to its simplicity, non-sensibility to rotation and scaling, and also because its acquisition requires minimal additional processing. However, by opting for this feature, which is color, we may face some serious challenges, such as complex background, meaning that we have in the input non-skin objects with skin-like colors, as we can see here, as well as luminosity variation, which drastically impact the skin detection accuracy. But still, as color is the most important feature, different color spaces are used for skin detection, such as RGB, HSV, and YCBCR, and each color space captures color information differently, as we can see here in this 3D color spaces representation. And for skin detection, we consider color spaces that separate luminance from chrominance, as this reduces the overlapping between skin and non-skin colors. So we will have color space for these color spaces. We will have one component that will represent the luminance part, and the other part will represent the chrominance part. As this will explain the motivation behind our choices, let's have a closer look at rule-based methods. To come out with the rules or thresholds, we have to analyze the skin colors distribution for the chrominance part, as it usually forms compact clusters with regular forms. Now, however, we cannot universally apply this, as this approach does not consider the luminance part, but also in reality, we will have different distribution for the skin colors dependent on the luminosity levels, as we can see here. So to resolve this problem, we have to consider this luminosity-dependent variation by treating the different values of luminance separately, which take us to talk about the proposed method. So how we did this, we chose to represent, sorry.
Yeah, you can change.
Is there any problem?
You haven't changed the slides. The slides of your PPT aren't changed.
Maybe it's connection issue.
It could be possible. You can maybe try.
Sorry, but I think the problem is that
maybe it's a connection issue, networking issue, I think.
Hello.
How about now?
Hello.
Yes, sir.
Yeah, actually, I would like to
Hello.
Here is that. Yeah.
Hello.
Yeah.
Can you hear me?
Yeah, sir.
I think it's a network problem. I think.
Actually,
no.
no.
Connection problem.
Please do the full screen of your presentation.
Can I continue?
No. Sorry. Actually, what I would like to add is, please full screen your presentation so that slides will be changed.
I'd like to request the presenter to.
Can you write it on the chat? I can't hear you. That is.
Could you please put your PPT in slideshow mode, full screen mode? Maybe then you can change it.
Yeah. How about this? How about this?
It's not working yet, I believe.
So what did you see right now? What are you saying?
Currently, your proposed method is visible. The slide for proposed method.
Yeah.
Yeah, but
now I changed
not
it.
in full screen.
Not in full screen.
Yeah.
It's I don't know. Or maybe I have to select the. Should I select the screen? I don't know if I have to select it or.
You can go ahead just like this. Like we have a time limit going on. So please go ahead like this. Just change the slides as you go ahead.
Yeah.
Yeah.
Okay. So how we did this? We choose to represent the skin color distribution with a 3D model. So we can consider both chrominance and luminance components. And we selected HSV and YCBCR color spaces, as these two are the most performing ones. And since it's not practical to analyze a 3D representation, we had to rely on a mathematical model. So in our method, we were inspired by the work of Kim et al. Presented in 2008. who used the B-spline curve to represent the skin colors distribution in a 3D plan. And to build this 3D model, they used statistical characteristics of skin colors distribution for the chrominance components. These statistical characteristics are the mean as the clusters, the skin colors distribution cluster, shift its center, and the second characteristic is the standard deviation as this clusters we have a change in size clusters. The chrominance components form a jointly Gaussian distribution given by this probability density function. And here this variable th corresponds to a threshold that will dictate the size of the ellipse formed by the function contour, as we can see in this figure. In our method, we improved the base model by adopting multiple 3D volumes as well as a local thresholds optimization, resulting in a model illustrated in this figure here. Let's start with multiple 3D volumes. Based on our observation, skin colors distribution form multiple clusters corresponding to the different skin tones. That's why we choose to opt for multiple volumes. Otherwise, we will inevitably include a significant part of non-skin colors in our 3D volumes. And for this purpose, which is the clustering, we use the degree scan algorithm. And after building the multiple 3D volumes, we proceed to the local thresholds optimization. So we start with a global threshold in the same way as the base model. After that, as it's not relevant to have the same threshold for the whole volume, we apply the local optimization for each luminosity level using the gradient descent expressed as follows. And then we finally arrive to the main part of our method, which is the skin detection. So let's recapitulate. We start with building the 3D volumes, and then we apply local optimization, resulting in an optimal ellipse at every luminosity level. And after that, for each pixel, we will identify the appropriate volume and ellipse. And then we will classify the pixels by testing as skin or non-skin pixels by testing if it falls within the ellipses. For the experimental part, we used the SFA, which is a data set containing face images with different light conditions and complex backgrounds, and also a variety of skin tones. And we use this matrix for to perform the quantitative evaluation. This table presents the quantitative results of different skin detection methods, including ours. And we can say that our method overall outperforms the method to which it was compared, including Kimi-All methods. And we can also say that the results obtained by using multiple volumes without local optimization are lower, which justifies our choice for the local optimization of the thresholds. Qualitative results also shows that our method, represented by the last one, performs better across different images, especially for dark tones. To recapitulate, we can say that our method have the best scores in terms of our method has the second best specificity with a trade-off for a way higher recall compared to the method that had the best specificity. And qualitatively as well, our method had a better skin detection across different images. Now, overall, HSV provides a better result than YCBCR. However, there is some cases in which YCBCR was better. And they are the cases when we have dark tones or low luminosity. So as combining both spaces can lead to superior results. To conclude, we can say that in this work, we presented a new skin detection method that explores the modelization of the distribution with 3D. This method provided significantly satisfying qualitative and quantitative results.
Excuse me.
And our method can still be improved.
I'd like to remind you of the time limit.
Yeah, it's the last slide.
Yeah.
Yeah. So our method can still be improved. For example, we can opt for an approach that will dynamically select the appropriate color space between the two color spaces we used based on the characteristics of the input. And we can also opt for different 3D modeling techniques. That's it. That's all. Thank you for your attention. Hello, can you hear me?
So you're audible. We'll be proceeding ahead with questions. If the chairs have any question, then you can ask. So,
No, it's okay, fine.
okay. So thank you, sir. We'll be proceeding ahead
thank
with
you.
the next presenter.
You are welcome. You are welcome.
I'd like to invite our next paper presenter, Aisha Irfan, with the paper titled Fusion of Hyperspectral and Multispectral Images for Land Use Segmentation. Ma'am, if you're here, then you can start your presentation.
Let me share.
Yeah.
Can you see it?
Yeah, it is visible. Please go ahead.
Okay. Good evening, everyone. The title of my paper is Fusion of Hyperspectral and Multispectral Image for Land Use Segmentation. Basically, I'm the doctorate student at the Beijing University of Technology, China. Okay, we'll have some content like introduction, background, the data set, methodology, results, and then finally we conclude the presentation. So land use, the main the idea of the research is basically based on the land use classification. So basically land use classification is the kind of arrangements or action contributions made by people for the creation, modification, or maintenance of particular type of land cover or land use. So it can be used for urban planning, environmental management, disaster control, health protection, biodiversity conservation, and so on and so forth in many fields. So there's some limitations in land use. So remote sensing and social sensing data and methods have been shown some good results in mapping urban land use categories, but they are still constrained by the mixed land use issues, some limited and low resolution data sets, some limited predictors, non-localized models, and often some relatively low accuracy. So there are two distinct notation when we talk about the land use. There are different notations, land use and land cover. So they are distinct terms. Land use is basically the kind of land which are for purpose, and land cover is the naturally covered land. So we are targeting the land for purpose. So here some related work has been done since 1970 to till 2022. So the blue bars indicates the kind of application on land use and land cover classification has been done on the all kind of remote sensing data sets. So there are different kind of remote sensing data sets from a different kind of satellites. And the 2002 to 2015, these show the publication on the land use and land cover classification of data set of hyperspectral remote sensing data set. And in 2015 to onwards, the deep learning techniques have been used for land use and land cover classification on all kind of remote sensing data set. And in this 2022, 2015 to till now, the most of the publication researchers have been using deep learning techniques for land use and land cover classification of both the hyperspectral and multispectral, both kind of data sets are being used now. So there are some frequently used data sets. I have reviewed different kind of data sets, and according to the literature, there are different satellites launched since 1919 to 2015, and they have different kind of resolution, different resolution. Their image type is SCR, pan, multispectral, or hyperspectral, and EO1 and the quick board are not still active. They have their dataset till some the years. But the Sentinel-2 is the most updated satellite for producing the multispectral imagery dataset with the high resolution. So there are some commonly publicly available datasets. And the most famous and mostly used dataset is Indian pines, which is collected from Indiana region, and it is basically the area of forest area. And there are some hyperspectral with this is the hyperspectral with pixel level ground truth, and there are some multispectral dataset with the patch level ground truth. They have been used in the research, but the mostly used are the hyperspectral datasets with the pixel level ground truth. So in my research, I used the dataset from EO1 satellite, which produces hyperspectral imagery data, and Sentinel-2 satellite for multispectral imagery data. So I acquired the data from this EO1 January 2017, and its spectral resolution is 30 meter with a 785 kilometer orbital latitude, and Sentinel-2 it's the latest because it's still active satellite. So we collected the latest data from the January 2023, and it provides the spectral resolution ranging from 10 to 60 meters, and it has the satellite orbital latitude of 705 kilometers. So basically, EO1 acquires the hyperspectral data, and Sentinel-2 acquires the multispectral data. Hyperons stand out as a widely recognized hyperspectral sensor, renowned for offering finely detailed hyperspectral data, and this data basically encompasses more than 200 narrow spectral band, spanning a broad spectrum with the electromagnetic range, and the Sentinel-2 satellite generates multispectral information utilizing a set of 13 distinct spectral bands and rendering them to appropriate for the kind of diverse array of remote sensing applications. So this is the study area selected for my research. So this is the name of the area is Chaoyang. It is one of the district in the Beijing. So I selected this area for our study. So the extracted area has basically the 23 bands, and a selected area is basically the central districts of Beijing. It covered all different kind of land use categories. So we selected this. That's why this area. For the main, according to the title, you can see that there is a fusion of multispectral and hyperspectral data set. So we fused actually the hyperspectral images from EO1 and multispectral from Sentinel-2 satellite to predict the kind of land used. So basically, the spectral image resolution of hyperspectral is mostly high, but the spatial resolution is mostly the low. And the multispectral sensor produce good spatial resolution, but with the low spectral resolution. So basically, the purpose of fusing these two was to get an accurate resolution from both of the satellites. So we from the hyperspectral and multispectral, we applied some pre-processing like atmospheric correction and some noise fraction, and on hyperspectral data for dimensionality reduction. Multispectral images contain quite high spectral resolution, and hyperspectral have high spectral resolution, which needs to fuse to ensure kind of more accurate results. So for the fusion, we use Gram-Sagemet pan sharpening method for sharpening the multispectral data by consuming high spectral resolution. So this method is more precise as it utilizes more specific sensor spectral response function to basically predict the data's appearance. So to check the performance of the applied method like fused image, we used the UNet model for segmentation, and we compared the hyperspectral image and multispectral image with the fused image results. And then we compared the accuracy to get to know whether the fusion method is most appropriate than for the combining the spectral and spectral resolution of both the sensors. So we used the UNet model, which comprises of basically the two distinct sections. The first part and the first part on the left side basically involves downsampling for extraction of low feature as of the input image and capturing the contextual information and resizing the images. And on the other hand, the second part allocated in the side performs symmetrical upsampling to gather high-level feature details from the image to ensure accurate positioning, and connecting these two parts in the middle segment. It is basically called the jump connection. So during the downsampling phase, the feature map is retained and merged with the feature map from the equivalent upsampling layer using a jump connection approach. So this strategy basically mitigates the resolution reduction typically, which is mostly associated with the use of maximum pooling layer. So we use the data set for the segmentation through the UNet architecture. So we have we divided in the 6 categories: the building, because it's the land used. So we have categorized in building area, in road, parks and greenland, water, soil, and there must be some other kind of classes, but we just separated in the other. So there are some sample of the generated results from the UNet model on the fused images. So UNet accuracy is finally we conclude the accuracy assessment is based on hyperspectral, multispectral, and fused images. So we use the confusion matrix for the performance evaluation of the segmentation model. We calculated the overall accuracy of the model by adding up percentages of pixels correctly recognized by the model in comparison to the reference label images. And then F1 score is calculated based on the precision and recall. And IOU, the intersection over union, is used to measure the similarities between two sample sets. And so from this accuracy assessment, as we can see that the fused image produced.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, sure.
Yeah.
So the fused image produced the highest accuracy, and they produced more accurate result than simply hyperspectral image and based on the simple multispectral images through UNet model. So I'll conclude it. Basically, the fusion is intended to, according to the experiment and or my research, I found that it is basically for increasing the visibility of information in images and the dependability of the digital analysis. So the ground experiment for fusion of hyperspectral and multispectral data using the imaging based on hyperspectral and multispectral resolution is a good approach, as it produced it achieved more accuracy on the fused images, while has a lower accuracy on hyperspectral and multispectral data set. And that's all. Thank you.
Thank you, ma'am. We'll be taking questions now. Sir, would you like to ask any question?
Hello.
Yes, sir.
Yeah, so I would like to know about what is the key importance. Means you are working with two different kind of the images,
Yes.
hyperspectral, multispectral, right?
Yeah, right.
So how these two are, we can say, differentiate. And second thing is, you are working with UNet model, right?
Right.
So what other models they are also appropriate?
Okay. So
You
as
will
I told,
apply.
the hyperspectral basically images produced by hyperspectral sensor. There's a problem that they have the their spatial resolution of hyperspectral sensor are mostly low, but the multispectral sensor produce good spatial resolution, but their spectral resolution is low. So one kind of sensor has a low spatial resolution, the other has a low spectral resolution, and vice versa. So combining these two, you're fusing these two different kind of imagery data is basically to balance the resolution, both spectral and the spatial resolution, from taking advantage from both of the kind of the images. So, and the second question, sorry, is about the unit model.
Yeah, actually, it was like that. You are working with the UNet model, right?
Right, yeah.
Yeah. So what other models which are, we can say, appropriately relevant to this UNet model?
Okay, we can use for this kind of data set, as I proposed. Basically, the major part was actually to check either the fusion works well with the remote sensing images on any deep learning or machine learning data. For since now, I work on a UNet model because they are more training, and for their good performance on image-based data set, I use this model. For the later research, I am extending this research to compare it with multiple models, because for this task, the major purpose was to fuse different kind of sensors. So we can check it later for the comparison, if it's a suggestion. So I'm working on it.
I would like to know about the exact use case. So I think you are using for land mapping, right?
A land use, right?
Land mapping means how ultimately you are mapping that, right? So I think now it is equally important that you have to clearly identify, because you have clearly mentioned what is the difference between hyperspectral sensors and multispectral, right? So now you have to identify that use case where this fusion will be helpful to you, because certain information is required with in-depth details. We required we have certain kind of the use cases where we required to go for in-depth details, right? So you have to identify those kind of the use cases or applications or case studies. So that is, I think, most appropriate to extend your work here.
Yeah, okay, sure. Thank you.
Yeah.
Thank you for your
Okay.
suggestion.
Okay.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next presenter. I'd like to invite our next presenter, who is David, with the paper titled Pertinent Issues in Artificial Intelligence System Adoption. So if you're here, then you can start your presentation.
Okay, thank you very much. I'll share my screen now.
Sure.
Let me know when my screen is visible.
It is visible. Please go ahead.
Thank you. So good evening, everyone. I'll be discussing my paper, which is titled Pertinent Issues in Artificial Intelligence Systems Adoption. So firstly, I would go through the introduction, the methodology, the theoretical brief, then the pertinent issues, and finally the conclusion. So the introduction, why AI? So AI, which is artificial intelligence, has become one of the cornerstones of the 21st century. It has diverse applications in sales forecasting, predictive analysis, and is used by various organizations. So AI consists of two subsets. These are machine learning and deep learning. So machine learning algorithms leverage on data, sample data, to build models and predict future scenarios. So you have various kinds of machine learning algorithms. You have clustering algorithms, you have segmentation algorithms, and all these have various applications in the health sector, in the banking industry, for customer retention, for customer satisfaction. And next, you have deep learning models. So deep learning models are based on neural network models. They can learn from large or vast amounts of data and have shown great success in sentiment analysis. So you see applications of deep learning mostly in computer vision and also for analyzing textual data. So they leverage on large amounts of data and they can provide more accurate results than machine learning algorithms in certain scenarios. So generally, AI systems help to improve the information processing capabilities of organizations by providing efficient ways to deal with vast amounts of data. Now, this data can be structured or unstructured. So this then provides accurate results for decision making. So despite these benefits, many organizations still face issues adopting AI systems and fully integrating them, particularly within the African context. Now, this ultimately prevents widespread adoption of AI systems in Africa. So you have certain pioneers in Africa like Nigeria and like South Africa, where you see various organizations that have adopted AI techniques, but then you still have other organizations that are slow to adopt certain systems, certain techniques. Now, this can be due to various issues, but this paper highlighted 4 main issues. These issues are: one, you have management support, then you have lack of skill sets, you have data privacy, and you have ethics. So the knowledge gap about these issues could lead to a failure to properly adopt these technologies and leverage their potential. And this can have a negative impact on the business and revenue generation. So this paper's objective was therefore to discuss 4 key issues that have shown to be persistent and pertinent to the adoption of AI systems. So you have previous studies in this area who have aimed to show either the success factors or the mitigating barriers to the implementation of AI systems, and they have used various frameworks. So now this study focused on 4 main issues. These issues were identified to be persistent and pertinent towards the adoption of AI systems. So in order to achieve this, a systematic literature review was employed. So the time period was from 2018 to 2023. And then, so various databases were searched using keywords such as artificial intelligence systems, issues, and adoption. So the initial result brought about 96 papers, and then there were certain inclusion and exclusion criteria that were applied. So the first criteria was papers that discussed issues such as management support, skills, data privacy, security, and ethics. So now papers that didn't adequately discuss the above issues and abstract-only papers were excluded. So now this brought the number to 43 papers. Then further exclusion criteria was applied. Papers that had repetitive discussions about these issues, they were further excluded. And this brought down to a final number of 24 papers. So of these 24 papers reviewed, it was identified that there were 2 main theories that were used. So this was the technology organization, this was the technology organization environment theory and the diffusion innovation theory. Now, these 2 theories were the most used theories when it comes to adopting AI systems. So now the TOE framework has 3 concepts. So it tries to audit an organization from 3 major perspectives. So namely, the existing system within the organization, the resources and size of the firm, and the competitor and market size. While the DIO has relative advantage, has compatibility, has complexity, triability, and observability. So one thing to note also was of these frameworks, there was no one single framework that helped to actually encompass all the issues when it comes to adopting AI systems. So that's why this paper didn't focus on the theory, but focused on the issues itself, because you would see papers where more than one theory was adopted to discuss certain issues. So there was lack of a framework that encompassed all the issues. So now I move on to the pertinent issues. So the first issue identified was management support. So under management support, we have lack of engagement from top management. We have little to no knowledge of AI systems. Then managers lack the appropriate technical skills and abilities, and you have a lack of solid managerial capabilities. So usually there's a lack of engagement from top management, and this can be tied to the fact that they have little to no knowledge of AI systems, and they don't have the required skills to operate these AI systems. So it's hard to convince managers of adopting a particular AI system or AI technology when they don't know much about it and they don't know how to use it. So now you have lack of skills. So this is lack of employee training and equipping with skills to operate AI systems. This is lack of in-house skills, then difficulty in acquiring the right individuals with the required AI skill. And lastly, you have inadequate managerial skill and capability, leading to lack of proper staff training. So now, the lack of management support ties into the lack of skills, because if managers don't have the required skill set or information about AI systems, then they're unable to actually train their staff with the required skills needed. So then I move on to the next issues, which are data security and privacy. So now for security and privacy, AI systems are usually more susceptible to privacy leakages. For example, you have model inversion attacks and you have extraction attacks. And also, as seen from the papers, there has been a growing customer concern about how their data is used and about the measures that companies use to protect the data of customers. Then you also have ethical issues such as the difficulty in pinpointing the accountability and transparency with black box AI systems. So AI systems and AI technologies, most notably deep learning models, which are quite hard to explain. So these are like black box AI systems. It's difficult to pinpoint accountability and transparency with them. And then you also have race and gender bias issues. So this is a summary of the 4 key issues that were identified. So now, what do these issues mean for managers? So in my discussion, I noted some points. So firstly, a manager should have knowledge about the technicalities of AI systems and endeavor to build capability and gain knowledge about the systems they plan to adopt. Now, this is very, very important, because I've seen there's lack of engagement from top management when they have little to no knowledge about AI systems. So to improve that, they have to gain knowledge about AI systems. Secondly, a manager should be aware of the importance of their role in building staff capabilities and ensuring that their staff are trained adequately so that they can use the AI systems that they adopt. Thirdly, managers need to be aware of privacy concerns around AI systems that they want to adopt. So this will inform them of certain defense mechanisms that they can employ to ensure protection of individual data. So you have defense technologies like you have differential protection, you have secure multi-party computation, you have security analytics, you have homographic encryption. So all this knowledge is required and is pertinent to using and understanding AI systems. Fourthly, managers must ensure that they adopt AI systems that adhere to government policies within their region. So one thing of note from the papers reviewed was that there were regulatory frameworks, most notably in the European Economic Area, such as the General Data Protection Regulation. Now, this framework helps to protect the privacy right of individuals. So therefore, within the African context, managers have to be aware of policies that are put in place by the government, and they must ensure that the systems they adopt adhere to those policies. Also, managers should let customers know what their data is used for and provide information on the AI systems employed and the measures put in place for the safety of their data. Lastly, managers can put humans in between the data collection and pre-processing phases of AI training to combat the issue of bias. So in conclusion, a proper understanding of these issues helps in the adoption of AI systems. And with the continuous development of AI systems and the persisting nature of these issues, continuous research on the nature of these issues is very important to help equip managers with the necessary information and knowledge needed to navigate these issues as they arise. Thank you very much.
Thank you very much. Mr. David, I have one observation. Do you have any model for your discussion proposed system?
Sorry, I didn't get that.
Do you have proposed architecture or model? I found some discussion or written text, but any model or technical architecture for it?
Okay, so from the papers reviewed, I did come across major adoption models for AI systems, which I touched on. So you have the technology organization environment, you have the diffusion innovation theory. So these are theories and models that have been used for adopting AI systems. But why this paper didn't focus on that specifically was because of the models that were found, no model actually captures all the issues. So for example, you would see that the TOE focuses on management support and lack of skills, and it focuses on if the AI system aligns with the organization. It doesn't really focus on your data security and privacy or your ethical issues. And you see that the DOI, that's the diffusion innovation theory, also focuses on lack of skills. So there was no one unified model. There's also the UAT model, but it still focuses on parts of the issues. So that's why the paper focused on the issues themselves, because these issues have shown to be persisting over the years, as opposed to focusing on the models.
Okay, thank you.
You're welcome.
Thank you, sir. We'll be proceeding with the next presenter. I'd like to invite the next presenter, Sebastian, with the paper titled POH IoT Design and Implementation of an IoT-based System for Tank Barrel Inspection. So if you're ready, then you can start with your presentation.
Yeah, hi everyone. Let me share my screen. Just give me a second. All right, can you see my screen? Is it visible?
Yes, sir, it is visible. Please go ahead.
All right, thank you. So I'll be presenting POH IoT, design and implementation of an IoT-based system for tank barrel inspection. So let's give some background. So despite being at peace at having cessation of hostilities here in Peru, it's important for our own safety and be precautious and have a vigilance army. So our cadets go through rigorous trainings daily, which involves usage of different military equipment. This includes war tanks. And so it's important for them to be properly maintained. So sometimes they might have some dust powder residues and so on. So in some cases, this might be the difference between life and death. So the current maintenance is done manually. We don't have proper equipment for performing this type of maintenance. And you know, the tank's barrel are quite large. They are 5 meters long, and they only have a diameter of 10 centimeters. So it's quite difficult to insert a camera per se. And so it's very difficult to perform this maintenance manually. There are out there in the market some specific equipment that could help us perform this maintenance. However, they're quite expensive or not available on our local market. And as well, that the tanks are not stored on the same facility. We have plenty facilities out there in the country. So, and the staff that performs this maintenance are not well trained in technology and so on. They're not experts on technology or usage of different types of cameras or user interfaces. So having this last year requirements in mind, it has to be a user-friendly user interface that has a cloud-based server in order to all the tanks on the different bases around the country to be connected and have same place to store all the data in real time if possible. So this is the robot that we implemented, the POH IoT. I'm going to quickly explain the mechanical procedures of this robot because we're focusing here on the software design. So you take this robot and you place it on one tip of the tank's barrel. And you insert this robot into it. It has a cable that connects to a computer in which the user can control the robot itself using a joystick. And so it can move forward and backward, and it shows live footage of the inside of the tank's barrel. And so we use artificial intelligence to first take pictures and then process each of these pictures and create a sequence that allows us to show all the faults found within the inside of the barrel. And with an EMU, we have the actual position from the 5 meters long the barrel has that the robot is located at. So we get all this information and we're able to find which part of the tank has specifically faults within. And so the methodology that we're following right here is the ADD, which is attribute-driven design. This is for the software design. This is a specific methodology used for software designing because this is what we're focusing on this paper. So first we have the usage cases. First these are the things that the software has to be able to do in order for a software to be successful and meet with the requirements. First, we have to be able to register barrels. In this case, for every single different cannon or barrel that we're registering, it has to have a unique name. This will serve as a partition key for then accessing the database. And let's say tank number 1, we can have all the registries done for this tank. Apart from that, every single image stores the time at which it was taken. So this serves as a sort key. So each entry has a uniqueness. Then we have to be able to display the following user interface. We'll see this on images later on the presentation, and be able to store this information within a database. In this case, we chose to use Amazon Web Services and store this in a DynamoDB. So we have access of this information from any different base that we could imagine in the country. And we have to display the current position of the robot itself to the user so they know how deep within the barrel they are. So you know this is 5 meters long, so there's when you insert the robot, you're not going to be able to see the robot itself from the inside. So you have to know what part of the tank you're positioned at. And finally, we have to alert the user whenever there's many faults found, more than we are supposed to. In this case, we're using a reference value of 7 faults per image. So whenever an image has more than 7 faults, it alerts the user that it's overpassed the maximum faults that it should have. So they should have proper attention to that part of the tank. So some requirements: the place that the robot will be used at doesn't have a very adequate Wi-Fi signal, is very low. So because of that, we're processing all the images locally in the computer and not on the cloud. Then it has to be a portable system because there are no power outlets to power the robot itself there in the base. And it has to be able to calibrate the encoder, so it has to show the position at which the robot is. So for calibrating the encoder and knowing the proper position. It's designed for a specialized user, so it has to be as friendly as possible, like the user interface. It has to have a low cost maintenance. So first, we chose a layered architecture that has 3 different layers. First, we have the presentation layer, which is the user interface itself. Then we have the extract, transform, and load layer, which we'll see later on what makes this special. And finally, we have the IoT layer. So now I'm going into depth with all those different layers and what we chose to use for each of these different layers. First, for the presentation layer, we chose the design tool Qt Designer that visually helped us design the user interface itself. And alongside the PyQt libraries, we were able to do the backend for this user interface and program this in Python. Then we used for the extract part of the layer, we used OpenCV library for connecting a camera so we could see the live footage of the robot itself. And so we could store this in a sort of video sequence and then process it later on the transform part of the layer. Next, we have the transform part, which is the machine learning algorithm part of the layer. We use the ultralytics library with YOLO-V8. So we took 500 sample images from some from different tanks. We mostly had to simulate these tanks with 3D printed barrel because we didn't have constant access to these tanks. They were quite classified, let's say. The base was very far away from where we did all this experimentation. And so we 3D printed a tank that simulates very similarly the actual tank itself. We took 500 different pictures for training a pre-trained network. So then we could the user just presses a single process button and it automatically processes all the images that the user has taken. In this case, the user is able to take pictures at the rate of 1 picture per second. This taking into consideration how fast the robot itself moves, because if it had more pictures per second, it would take more time to process, and it wouldn't give enough time to the robot to actually move, change the position. It would show the same image. And these are all stored within a CVS file, with information such as the time it was taken, the position at which it was taken, and the number of faults that it found, the position it took, and the name of the tank itself that it corresponds to. Finally, we have the load part of the architecture and the IoT core part of the architecture. For the load part, we use, as I mentioned before, the Dynamo database to upload all this information that I previously mentioned. And we use the Amazon Simple Notification System to alert the user whenever there is more than 7 faults found within a same image. And for the AWS IoT core, we use this. So there's a main base that kind of subscribes to the information performed by the different bases spread around the country. So this is called MQTT communication architecture. And so let's say a user from base A posts the information on tank number 1. And with this MQTT communication, the user on the main base can see at real time all the measurements that are being taken from this specific tank. And it can receive the warning as well, whether there's more than 7 faults on the same image or not. And this is better understand here in this image, because we can see it visually. So where the tank takes pictures with visual libraries, the relevant inspector has the measurements at which its picture was taken. All the images are pre-processed. Then with the OV8 architecture, we get the images are processed and we find the faults for every single image. And there's like a video sequence created. All this is uploaded into a CVS file, which is then uploaded to the Amazon DynamoDB. And with the Amazon IoT core, we're able to see this in real time. The supervisor logs into a computer and just sees this in real time and gets an email whenever there is more than 7 faults, as I previously mentioned. And well, this would be the user using the user interface to control this robot and do all of this image processing. Now for the tests that we run to make sure that all this was okay. First, we have the actual mechanical test of the robot that I'm gonna leave for the end in case we don't have enough time. But the most important, the failure detection, as I mentioned before, we had to pre-print a barrel that simulates the actual barrel of the tanks because we didn't have much access to the actual tanks themselves. But these added we were able to test the mobility of the robot itself, so it's very helpful. Next, we have the uploaded data tests. In this case, we had one of our team members post this information from a specific tank from one computer, and a second user logging into any MQTT tool to subscribe to this sort of information that is regularly posted and see whether it would receive the actual information or not. Next, we had the warning test. First, we kind of got an image and we visually counted how many faults. In this case, the faults are represented by holes because we didn't have actual access to the real tanks. But this is sort of the type of fault that were commonly found within the tanks. And so we visually counted how many holes or faults were found. And we checked whether the program itself would give out the same amount of faults, whether it would detect them on their appropriate place that they were located at, and then see if whether it would send the warning or not. So now let's check on the results that we got from this. First, for the failure detection results on the image, there was the image from before. Visually, you can count that there are 10 faults that are found within the inside of this section of the barrel, and it properly shows the number of failures that it had. 10 in this case, shows the position in which it was located. So this is 27.3 centimeters, which is quite on the start of the barrel. We have the lifetime footage of the camera itself, so the user can guide themselves and know in which part of the barrel they are located at. The user interface is quite friendly. It just has simple buttons. For example, for processing, it automatically processes all the images instead of processing one by one. So it makes life easier for our users, which, as we can remember from before, are not specialized in tech or any sort of those things. Next, we have the data storage. This doesn't necessarily correspond to the images before. So this was taken a few weeks ago. This is the data that we had. So this stores the time at which the image was taken. In this case, it was taken last year at this time around 7 p.m. The distance from the barrel at which it was taken and the number of failures that it detected. So this is properly stored within the Dynamo database. And finally, we got the warning test.
You speak now? I'm really
Yeah,
sorry
sorry.
to disturb you, but I'd like to remind you of the time limit.
Yeah, sorry. I just, yeah, I think I'm done. So that's that's basically it. Sorry for taking too much time. I ran out of time, but yeah, thank you very much.
Thank you very much for your nice presentation and explanation. I
Thank
have
you.
no question.
Yeah, thank you.
Yeah, so your presentation was very informative, and we can see that you have done the excellent work that is reflected on your presentation. So with this, I do not have any question, but you have done very good job. Yeah, good work.
Thank you very much.
Thank you. So we'll be proceeding ahead with our next presenter. I'd like to invite our next presenter. With their paper title, Solving the Crossword Generation Problem Using Parallel Programming in Modern Browsers, a case study. So if you're here, then you may start your presentation.
Good afternoon. Hello there. I'll start my presentation. Just a minute,
Sure.
please. Yes, I've been started. Are you seeing it?
Yes, sir, it is visible. Please go ahead.
Okay, thank you. Good afternoon again. My name is Caleb. Sorry. Just a moment. Okay, here. Hello again. My name is Caleb, and my student Daniel and I will present our research paper called Solving the Crossword Generation Problem Using Parallel Programming in Modern Browsers, a case study. First of all, I would like to thank you, ICT and ICICT 2024 organizing committee to be here at this virtual conference. So we prepared the presentation as following. First of all, we'll talk a little bit about our main goal. After that, we'll briefly talk about WebAssembly and web workers. After that, we will explain the main problem, the crossword generation problem, following by our solution using WebAssembly, web workers, and of course, parallel programming. In the end, we will present some results and basically our discussion. Well, nowadays we know that the internet has become a standard for developed application. We can see it when you read some materials published by the World Wide Web Consortium, the W3C. These standards, of course, mainly force the browsers to offer some standards to develop some applications, and because of that, we can see a tendency to migrate some applications from the server side somehow to the client side. So these standards, such as WebAssembly and web workers, call our attention, and we try to develop a multi-paradigm and a parallel solution using these technologies. So we can say that why web applications are become more complex nowadays. Our main goal in this research paper is to use those features to create a parallel version of a backtracking-based algorithms, for instance, the crossword generation problem. I now call Daniel that will continue the presentation of all. Please, Daniel, are you here?
Yes. So we're gonna talk about two main tools we used that are available in modern browsers. The first one, WebAssembly. So basically, traditionally, JavaScript was the only language that was available to use inside the browser. And with that, we are locked with some features from JavaScript, such as garbage collection, dynamic typing, and others that maybe can harm our performance. And WebAssembly enables us to use languages such as C++ or Rust or many other compiled languages in a way that we can use them inside the browser together with JavaScript. And we have a study from Herrera from 2018 that WebAssembly cannot perform JavaScript in many similar tasks. So the other tool is Web Workers, and this is basically a way for us to use virtual threads inside the browser. So if you want to use parallel programming, Web Workers is our tool. The idea is the main thread from the browser is going to be serving the user with visuals and interactivity. And in the background, you can spawn Web Workers threads, which they're going to do more complex computations in the background without blocking the user view. So we did a little example here just to understand how are the workers, how we create them. So in the first image is the worker.js file. We basically say we're gonna the first image is the main script. We basically say we're gonna spawn the worker.js file. We're gonna send it a message with 1 as the data, and we're gonna register a handler that's gonna receive a message from the worker, and we're gonna console log the message that we receive. In the second image, we register the worker.js file, and here we say we're gonna just receive a message from the main script. We're gonna log what we received, and we're gonna post back the message +1. And in the third image, we see the results of this experiment. Basically, the worker receives 1 from the main script, and the main script receives 2 from the worker. Now, web workers can be very helpful, but it's important to mention that it has a very high startup cost as well. So if we start to spawn many web workers, it might do more harm than help us. Okay, so for the crossword generation problem, which is our case study, we developed an application that solves this problem inside the browser. Basically, we have a grid of words, and we want to find words to fill this grid, satisfying the restrictions of the intersections. We have to have the same letters. For example, this 1 here has to be the same letter for the first word and the second word. This is an NP-complete problem, a problem that can be very time-consuming to solve, and it can benefit a lot from parallel programming. In our solver, we encoded the grid as letter identifications. So we have, for example, these 4 words: 1, 2, 3, 4. We encode them as letter IDs, and we see that, for example, the words encoded use the same letter ID for the letters that have intersections. So the solver knows what are the restrictions it has to work on. And with that, we basically search through the dictionary for words that satisfy these restrictions. And if we can't go forward, finding more words, we go back. So if you can't find a word here that satisfies the restriction of the 1, we go back, change the word of the first search to use another letter in the middle, and then we go forward. So our solver works with this, with backtracking, and it gives us back basically a mapping that gives us the actual letters for each letter ID. And with that, we can finally display in the screen the final results. Next slide, please. So the way we solve this with parallel programming, we can think of this solution, the solver, as basically a depth-first search-based algorithm, because it's going to basically try to find the first solution in one branch of a tree. If it doesn't find a solution, it backtracks, chooses another branch, and then tries to find another solution. And it keeps doing this until either you find a solution or you search through the whole tree without any solutions. And so the way the approach we used here, basically we got the first word that's going to begin the search, and we split the dictionary available for the first word between the available threads. So in this example, if we have 4 threads, we would give the first thread A to G, the second G to M, the third M to S, and the fourth S to Z, in a way that they will start the algorithm with a specific set of words. And of course, for all of the other words, they will have the full dictionary. So it means every thread will be working in parallel on a different part of the tree, and therefore we have better chances at finding a solution faster. Next slide. So the results and discussions, basically we found out that we had super linear speedup in some cases, and the speedup was non-linear in every case. And that is defined by that can be explained by the non-determinism of the solution. So basically we can't know which thread will have the best solution, which word has the best, has the faster way to reach the final solution. And so when we add more threads, we add more chances to find this fastest solution. Because if we just have a sequential one thread, you're going to start from the first word of the dictionary. Maybe if the solution is in the last word of the dictionary, we're going to search through the whole dictionary to find the solution. If we have more threads, we have better chances at starting closer to the solution. And so we can observe the good results, especially in bigger grids. In smaller grids, such as the 5x5, as the blue line we see in the graphics, we see that we actually got a decrease in speedup because the cost of having web workers doing computation was actually did us more harm than helped us, in the sense that we don't have that many solutions that having more threads can help us, and having more web workers is more time consuming. So in smaller grids, we didn't have good solutions, but if we see at bigger grids, such as the 12x12, the gray line here, we see that with 4 threads, for example, we had a speed up of 42. And that is a super high speed up, and it can be explained because, as I was saying, the solution could be in one of the words that any of the 4 threads received. But if you look at using more threads, with 8 threads and with 16 threads, the speed up decreased. We still had the speed up, but it decreased. And that can be explained by the cost of web workers. And the solution could be in one of the 4 starting threads. And if we add more threads, it's not going to help us because we already had the solution just with 4 threads. And also the processor we used in this experiment had only 8 cores. So adding more threads than cores available would also harm our speed up. Yes, so I give it back to Caleb now for our thanks, but this was our conclusion.
Okay, thank you, Daniel. Would like to thank you, the ICICT 2024 Organization Committee, to be here. Thank you, people. I would like to thank you, Mackenzie Presbyterian University, and some other sponsors, Sprace, FAPESP, and McCall, that support us doing our research, and also to be here presenting this research paper. Thank you.
Thank you. Can you explain us the real life application of this system?
Yes, it's basically an application that has a grid. You can draw your grid. You can fill in the squares which will have words and will not have words. You can choose the size of the grid, and you click a button to start the search, and it's gonna try to find a solution to fill that grid with words. And initially we had a sequential version of this application. And what we did was parallelize the solution in a way that we had many faster results.
Okay, thank you.
Thank you, sir. So, Kirit, would you like to ask any question?
Oh, no,
Okay.
it's okay, yeah.
Thank you, sir. This was the last presentation for the session. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2024. I'd also like to thank our session chairs for chairing the session. A token of appreciation on behalf of Team ICICT 2024 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
So thank you, Isita, and I'm thankful to even and I congratulate to all the authors who presented their work. And I appreciate the efforts put by all the authors, and I hope that in future they will come with some more insights, some more results, and it will be more, I think, helpful and beneficial for the research community. Thank you.
Thank you, sir. Before we end the session, I'd like for everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone.